Hello everyone, this is part 2 video on past year NEET questions from the chapter polymers. Now those who are looking at this video, right, can also take a look at the other part, which is the first part, so that you can have continuity of questions. We'll start with a question that has come in 2013 paper. Which is the monomer of neoprene in the following? So neoprene is also called as what? Polychloroprene. So from this itself we will know what is the monomer. What is the monomer? Chloroprene is the monomer. So chloroprene, what is chloroprene? CH2 double bond CCl, CH double bond CH2. So we'll have a double bond between first and second carbon and third and fourth. So it's an unsaturated monomer and it undergoes addition polymerization. Neoprene is example of addition polymerization, right? So how the addition will occur? If you are having CH2 double bond CCl, single bond CH2. Okay, so this is one unit. CH2 double bond CCl, CH double bond CH2, and this is going to repeat this side also. Now how the addition will occur is if you are just looking at it, right, so there will be an additional bond that will be formed here, same this side also and this side also, because it will be a linear chain. Neoprene is also example of what? Linear chain polymer. Okay, so as a result of the bonds formed, right, here this double bond will be removed, this double bond will be removed, this double bond will be removed, this double bond will be removed. As a result, right, look at it, in each monomer unit, let us number them 1, 2, 3, 4. Second and third carbons are now deficit of valency, one less. Here also, if you mark them 1, 2, 3, 4, second and third are one deficit of valency because we are removing the double bond engaging them, right? As a result, they would form the double bond. So you see here neoprene, the repeating unit, right? The double bond between second and third carbons. So in fact, this is also important, the structure of or the shape of the neoprene. So in the repeating unit, we'll have a double bond between the second and third carbon. Okay, but for this question, what is the answer? It is option A, which is chloroprene. And here couple of things that will be important to notice are, one is neoprene, it's an example of linear chain polymer. It is also example of addition polymer. And for the addition polymers, we will be requiring what? Unsaturation in the monomer unit. Which one of the following is not a condensation polymer? So in fact, this is a question that has come in 2012. We can see how the things will be repeating around neoprene. In fact, you will be seeing at least in this video, lot of questions have been asked about this neoprene or related to the neoprene. Okay, so look at this one. They're asking which is a not condensation polymer. Just now only we discussed, right? So what is a condensation polymer? Typically, when the monomer units, they don't have unsaturation, right? When the polymer is getting formed, there will be a loss of water molecule or ammonia or HCl or even sometimes alcohol. So the removal of these molecules will enable the formation of the polymer. That is what we call as the condensation polymers, right? Neoprene, just now only we saw, is not a condensation polymer. What is it? It is an addition polymer because the monomer units, right, will have unsaturation. So for the addition polymers, monomers need to have unsaturation. So you can see here the monomer unit will have two double bonds. One is between carbon 1, carbon 2, other is between carbon 3, carbon 4. Neoprene will have a double bond between, in the repeating unit, we'll have a double bond between carbon 2 and carbon 3. Okay, so what is the answer for this? Because neoprene is an addition polymer, right? It is not a condensation. The others, right, melamine, formaldehyde resin, glyptol, dacron, all these are examples of the condensation polymers. This is the kind of theoretical question that has come in 2012. Which of the following statements is false? So we need to identify which is the false statement. Option A is artificial silk is derived from cellulose. Yes, I mean, you know, the artificial silk, right, is derived from basically cellulose. That is the correct one. Option B is saying nylon 66 is an example of elastomer. So nylon 66 is what? It is not an example of elastomer. Elastomers are typically our rubbers. Nylon 66 is an example of what? It's a fiber. So this is incorrect or the false. So I think we got our answer. They're asking for what? Which is the false, right? So the option B is the false one. but we look at the others also. The repeating unit of natural rubber is isoprene. So what is the natural rubber? The rubber that we obtain from the latex of the rubber tree, right? So what is the repeating unit? It is the cis 1,4 isoprene. So the polymer will be hence called as what? Cis 1,4 polyisoprene. So this is the natural rubber is what? It is a cis form. Even I think in one of the previous questions also we talked about it. There was a question that has been asked whether the natural rubber is a cis form or a trans form. What is it? Is a cis form. Okay. So this is of course correct. Option D is what? Both starch and cellulose are polymers of glucose. So this is a question related to the biomolecules chapter also, because there we'll study in detail about the structure of glucose and how the starch and cellulose will be formed from the glucose. So what is the starch? We can also call it as the amylum. It's a carbohydrate polymer. So the glucose units will be joined by the glycosidic bonds. Okay, so we'll talk about this in biomolecules because it is not so much required here, but the thing that is required is the repeating unit of starch is what? It is the glucose. Same will be the case of the cellulose also. Cellulose is the plant polymer. So the it's a polysaccharide consisting of several hundreds of the D-glucose units. So you can see that 1, 2, 3, 4. So 1,4 bonding, right? So the first carbon, and you can see here also what is it? It will be 1, 2, 3, 4. So 1,4 bonding will be there between these D-glucose units. So that is what is about the monomers of both cellulose and then starch. So in these 4 options, right, the incorrect one or the false is what we are looking for. What is the false one? Because option B, they are saying nylon 66 is a elastomer. It is not elastomer, it is what? Fiber. So nylons and rayons are examples of what? Fibers. Next we have a question on biodegradable polymer. You see, even in the part 1 video we talked about 2 questions on the biodegradable polymer. Just we have 2 examples for the biodegradable polymers. One is the nylon 2 nylon 6, other is PHBV. Which one of the following sets forms biodegradable polymer? So you can see here clearly in where? In the option B. What do we have? This is glycine, and what is this? This is the amino caproic acid. So glycine and amino caproic acid, right? They will undergo polymerization to give nylon to nylon 6. So here the nylon to nylon 6, right? This can be taken as an example of condensation polymer. Why? Because you see here what is going to happen? OH from the COH group and hydrogen, one hydrogen from the amine group, that will be removed as what? Water. Okay, so this is the reason why we will consider this as condensation polymer. Okay, so the nylon 2 nylon 6, right, is a copolymer, okay, of what? Glycine and then amino caproic acid. Okay, and we can also take it as an example for the condensation polymer because it is happening due to the loss of water molecule. And this is a biodegradable polymer which is used for the stitching of the wounds, etc. The other biodegradable polymer is PHBV. Okay, so even in one of the other questions we talked about what are the monomer units for the PHBV. Okay, so the correct answer for this is option B. Next we have a question that has come in 2011. Of the following, which one is classified as polyester polymer? Okay, so polyester polymers, they are basically formed when your monomers, one is an alcohol and other is an acid. So if you look at the formation of terylene, terylene is the commercial name, also it can be called as dacron. So in fact we have already one question that has come on the dacron or terylene. So the chemical name for this is polyethylene terephthalate, which is also in short called as a PET. So that is the one that is used for making of the PET bottles, etc. Okay, so the ethylene glycol, which is an alcohol, and terephthalic acid, which is an acid. So they undergo the condensation polymerization. So we can see here that the hydrogen from the alcohol group and OH from the acid, they will get removed as water, and what we'll see is an ester. So what is it? It's a polyester. So terylene or dacron, or we call it as also PET. It is an example for the polyester. Nylons are what? Nylons are polyamides. Next we have another question on the neoprene. Which of the following structures represents neoprene polymer? So already we talked about it in one of the previous question. What is it? If you look at the chloroprene. So what is chloroprene? You'll have unsaturation, a double bond between carbon 1 and carbon 2 and carbon 3, carbon 4. So they undergo addition polymerization, where we already discussed about it before, but we'll do it one more time. So we'll have this is one unit. We will write down the other unit also, and this continues. So the addition bonds that get formed to finally form the linear chain of neoprene. Neoprene is, by the way, also called as what? Polychloroprene. Okay. So this side we'll have a bond formed, addition bond. This side here we'll have a bond, here we'll have a bond. As a result, the monomer units, double bond between 1 and 2 carbon, 3 and 4 carbon, the double bonds will be removed. So what we'll have is unsaturation. What we'll have is the valency deficiency between carbon 2 and carbon 3, because the double bonds involving them, they have been removed, right? Now this carbon 2 and carbon 3, they will form a double bond. That is what is the final structure of neoprene. So neoprene will have 4 carbons, double bond between second and in the repeating unit, double bond between second and third carbon. Chlorine will be on the second carbon. That is it. Okay, so look at it, option A, right? What is it? We'll have the 4 carbons in the repeating unit, second carbon chlorine, and also double bond is between second and third carbon. Next we have a question that has come in 2009. The structures of some common polymers are given. Which one is not correctly presented? So in fact, this is also a question related to what? Neoprene. So we'll see. So neoprene, what is the process for the formation? It is formed from the chloroprene, right? So chloroprene, the homopolymer. This is also example of what? Addition polymerization, because the monomer is having unsaturation. Will give rise to linear chain of the neoprene, which is also called as polychloroprene. So neoprene, right? What we'll have? We'll have 4 carbons in the repeating unit, but here you can see 1, 2, 3, 4, 5. So the one that is not correctly represented. So neoprene, right? The repeating unit will have 4 carbons, carbon 2 and carbon 3 double bond, carbon 2 chlorine will be attached. So which is not correctly represented here? It is the neoprene structure that is not correctly represented. Others are all correctly represented. Terylene, which is also called as a dacron, that is correctly represented. Nylon 6,6, we can see that between 2 nitrogens 6 carbon units will be there. Between 2 CO groups 4 carbon. Totally it will be what? 6 carbons here. Here also 6 carbons. Teflon. Teflon is what? The repeating CF2 units. Okay. So all these are correct except the option A, which is the neoprene. Next we have a question about the rubber. This has come in 2008. Which one of the following statements is not true? Buno-S is a copolymer of butadiene and styrene. So Buno-S is also called as what? Styrene rubber, because it has got styrene as the monomer. Okay. So the option A is correct. Option B is saying what? Natural rubber is a 1,4 polymer of isoprene. Okay. So natural rubber, right? What is it? It's a polymer of 1,4 isoprene. So that is also correct. So isoprene, we can see that we'll have the repeating units of isoprene that will form a polyisoprene. It will be a cis form. So cis 1,4 isoprene. So that is what is the natural rubber that is obtained from the latex of the rubber tree. Okay. Option C is saying vulcanization, formation of sulfur bridges between these chains will make the rubber harder and stronger. That is correct. I mean, based on the variation of the sulfur content, the properties, the physical properties or the hardness of the rubber, vulcanized rubber will be varying. Okay, so that is also correct. Option C is correct. So the vulcanization, sulfur bridges, right? They'll actually make the rubber harder and stronger. Option D is what? Natural rubber has trans configuration at every double bond. That is incorrect. Why? Because it is a cis. So what is the trans one? Remember, we talked about it in one of the previous questions also, the gutta percha, right? That is the trans. And because of that reason, the gutta percha will have lesser elastomeric nature. Gutta percha will have lesser elastomeric nature than the natural rubber that is obtained from the latex of the rubber tree. Next, we have a question in 2007. Which one of the following polymers is prepared by condensation polymerization? So we are looking at what? Condensation polymerization. Okay, the options are Teflon, natural rubber, styrene, and nylon 66. So condensation polymerization means what? There must be a removal of either a water molecule or a HCl or ammonia or even sometimes alcohols. If you look at it, right, already we have talked about this in one of the previous questions also. The nylon 66, which is having adipic acid, 6 carbon chain acid, and hexamethylene diamine. So here we'll have 6 carbons, here we'll have 6 carbons. The hydrogen from the NH2 group and the OH from the COH group, they will be removed. So the loss of water molecules. Loss of water molecules will give rise to condensation polymerization. And we'll see that in the nylon 66, I think in one of the other questions they have asked even what is the shape or structure of the nylon 66. Between two NH groups we'll have 6 carbons as it is coming from the hexamethylene diamine. Between two CO groups we'll have 4 carbons as it is coming from the adipic acid. That is the repeating unit. So the nylon 66 is example of what? Condensation polymerization. So addition to polymerization will happen when there is unsaturation. Natural rubber, Teflon, all these are, they are formed from the unsaturated monomers. Next we have a question that has come in 2006. NH CH2 6 times, NH CO C2H2 CH2 4 times, CO, that is the repeating unit. What is this? This is the repeating unit for what? Nylon 66, right? Because we have the hexamethylene diamine. Between two nitrogens we will have 6 carbons and adipic acid, 6 carbon acid. So the polymerization of this, right, will be giving us what? Nylon 66. And this happens because of loss of water molecule. So hydrogen from the NH2 will be removed and OH from the COH. Loss of water molecule will give us the nylon 66. Okay. Now, is it example of addition polymer? No, right? Why? Because this is a condensation polymer. That is happening because of the loss of water molecule. Is it a homopolymer? No. We have 2 monomer units. That is also not correct because homopolymer means what? Only 1 monomer unit. Is it a thermosetting polymer? Nylon 66 are what? They are fibers. This is not thermosetting polymer. So thermosetting polymers are what? Typically the cross-linking polymers. Option B is what? Copolymer. Yes, it is a copolymer of what? Adipic acid and hexamethylene diamine. The correct answer for this is option B. So this is about the part 2 video, and we will see in the next part.